Today we're going to look at similar polygons. Over here on the left side we have two items that appear to be parallelograms. We can just call them quadrilaterals for now. And we also have two triangles over here. It says in our instructions each pair of polygons is similar, and that's an important thought to consider. We already know that they're similar. Then asks us to write a similarity statement, find the value x, find the measures of the indicated sides, and the scale factor. So the first thing I'll do is I'll find the similarity statement. Now when finding the similarity statement here, since I already know that they're similar, I'm going to write a symbol for quadrilateral, parallelogram, whatever you want to call it, and I'll have to choose an order in which to write my vertices. Now the simplest way is to go in alphabetical order, so long as that the vertices you write down are in consecutive order. So I can write A, B, C, D. And then my symbol for similarity looks like a squiggle, is similar to. And now I'm going to write down my next polygon. I have to remember that whatever goes here must go here, and so on. So if I have the single arc mark for A, then I have to write down the single arc mark L on this side. And then we move. The double arc mark B has to go along with the M. The triple arc mark C has to go along with the N. And then the last one, the quadruple arc mark D, has to go along with P. Alright, so the similarity statement tells me, first of all, which angle of one polygon is congruent to the angle within the other polygon. It also gives me information about which sides are proportional. So I wrote my similarity statement, checked. Now find x. Okay, to find x, I'm going to have to create a proportion. A proportion is when I have two sides set equal as an angle to two other sides. And I will choose this side, since I have information about it, 14, over its corresponding side, the one that's going from the single tick to the double tick. So I'll choose this side right here, 14 over x plus 9. You'll note that AB appears here, and that's also similar to LM, which is here. The first two vertices of my similarity statement are going to be corresponding to the first two vertices of my second similarity statement. 14 over x plus 9 is then going to equal, well, I have this side, so I'll write 10, over the 2 to 3 tick mark, which would be x plus 6. So now I have my proportion. 14 over 19 equals 10 over x plus 6. I'll then simply just multiply cross products. 14 times x plus 6, and set that equal to these two. This is called the cross products property, or the means extremes property of proportionality. Basically, if you have a fraction equal to another fraction, it's called a proportion. You cross multiply and set those things equal to each other, and now we have an equation that's easier to solve. So I will go ahead and distribute 14x plus 84, that is 14 times 6, equals 10 times x is 10x, plus 10 times 9 is 90. Here I have an equation with variables on both sides of the equal sign, so I'll go ahead and find the smaller amount of variables and eliminate them. Do the same thing on the other side of the equation to maintain its balance. This gives me a 0, so I have 0 plus 90, or 90 equals 4x plus 84. That's not how you spell 8, there it is, 84. And then I'll go ahead and just simply follow my two-step equation solving techniques. Attack the addition subtraction part first to have 4x equals 6, and then divide both sides by 4. X equals 6 over 4, or 3 halves is fine, You could also write x equals 1 1/2 if that makes you happy, or 1.5. But anyway, we found x. X equals 3/2. Find the measure of the indicated sides. Well, as I look here, I need to find this side. So I'm going to write down here NM equals 1 1/2 plus 6. That would be 7 1/2. Remember, x equals 1 1/2. And 1 1/2 plus 9 would tell me that ML, this side, equals 10 1/2. 9 plus x. 9 plus 1 1/2. The scale factor is going to be 14 over its corresponding side. The scale factor is often written as a k. So down here, I'll write scale factor k equals. I had 14 over x plus 9. I can't grab it. So I'm going to write 14 over this number, 10 1/2. Now that's an ugly complex fraction. We don't want that. So I'm going to rewrite that as 14 divided by, and instead of 10 1/2, I'm going to write 21 over 2. I'm going to change that to 14 over 1 times, dividing a fraction is the same thing as multiplying by the reciprocal. And I could go ahead and multiply straight across, but you know what? I'm going to go ahead and cancel out the greatest common factor, which is 7. Divide by 7, I get a 2. Divide by 7, I get a 3. And now I'll multiply straight across. 2 times 2 is 4. 1 times 3 is 3. And my nicer scale factor, instead of 14 over 10 1/2, I just rewrote it as 4/3, because that's the same fraction, only I don't have the complexity of a mixed number in my denominator. That's bad. This is a much cleaner looking fraction. It's actually the only correct answer I'll accept, 4/3. So we knew the polygon was similar. We created the similarity statement down here, making sure that all the vertices of one triangle corresponded to their congruent vertices of the second one. We then found x by setting up a proportion. We found the missing side lengths by plugging x back in. And then we found the scale factor by just taking one of these ratios. Didn't matter which one we chose, we just went with this one. Put in our side lengths, and then rewrote it until we got a proper fraction. That's it. Hope you enjoyed it. Bye-bye.